Okay, well, welcome to the Introduction to Microsoft Excel module. The purpose of this module is to teach you some of the basics of using Microsoft Excel. The Microsoft Excel program is called a spreadsheet, and a spreadsheet allows you to manage, manipulate, and display data. So quickly, some Excel basics. You can see here we have a grid that's comprised of columns and rows. The columns are denoted with letters A, B, C, D, E, F, G, and the rows are denoted with numbers. And each of these rows and columns forms what's called a cell. And you can see up in the corner here, whichever cell I have as being the active cell is also noted up in the corner here. So for example, here we have C9, and there we have C9. The other thing we have in Excel is what's called the formula bar, and that's this white area right here. Formula bar shows what the contents are of each cell. So for example, here if I go to cell A5, it just has the number 10 in it, and that just shows up as a 10 in the formula bar. If I go to cell B5, now I'm calculating the area of one side of a cube, and so that should be the length squared. And you can see here in the formula bar, we have the formula equals A5 squared. Other things you need to know about Microsoft Excel, we have what are called the worksheet tabs, and so those are down here. You can have multiple worksheets in one workbook. Here I have two worksheets. If I wanted to add more worksheets, I would just click on this button right here, and I can add as many as I want to the end. And we also have menu tabs. Those of you that are familiar with Windows, Excel for Mac might be slightly different, but we have all the different window tabs up here. And so here's all of our editing functions. We can insert pictures, charts. We'll get more into that later. Page layout, you can adjust what the page looks like. The formulas, we'll talk a little bit about this later. These are some of the formula selections that we can use in Excel, and different types of data manipulation, review if we want to do word count, thesaurus, spelling check, those sorts of things, etc. Okay, that's kind of the basic of the interface. Let's talk about how we handle and manipulate data in Microsoft Excel. So as we said, active cells contain the results of a formula, and the formula bar shows the formula. Here I have a little worksheet worked up where we're going to calculate the properties of a cube. We have the edge length, the area of one side, the surface area of the entire cube, and then the volume. And I already started one row for a cube that has an edge length of 10 inches. Now let's say I also wanted to perform the same calculation for multiple cube dimensions. So say we wanted to look at a cube length with an edge length of 15 inches, 20 inches, 25 inches, etc. Okay, I'll show you how we can do that, how we can quickly generate those edge lengths if we were just to say that the next edge length here is equal to the previous edge length, A5 plus 5 inches. That'll then bump up this cell to 15 inches. Now, as I copy this cell down, so if I click on this little black square right here and I pull that cell down, it's going to copy that formula to all the next cells. And as it copies that formula, it's going to update the number, right? So when I click on this, you can see that A5 is highlighted because that's the cell that's used in the formula. If I were to go to the cell below, it updated the number from A5 to A6. If I click on this formula here, you can see that A6 is highlighted in blue and the cell is highlighted in blue, and so on and so forth. So as we go down, the number of the cell is updated accordingly. Okay. The area of one side here, so we're just taking the edge length squared. Now I can copy that formula down again by grabbing the little black square in the corner and then pulling it all the way down, and that's going to then just keep the same formula and update the number A6, A7 squared, A8 squared, A9 squared, etc. So I'm now calculating the area of one side squared as the edge length goes up. Next, we can then look at the surface area. Well, the formula for the surface area is going to be the area of one side times 6 because a cube has 6 sides. So that's just 6 times B5. And again, if I were to grab this little black square, copy that formula down, it would then update all my formulas. So I'm now calculating the surface area for all these cubes with different edge lengths. Finally, if we want to calculate the volume of our cube, well, that's just going to be the edge length cubed. So edge length raised to the third power right there. And so if I were to grab that little black square and copy it down, it would then calculate the volume for all those cubes. So that's just a brief overview of how we manage and manipulate data in Microsoft Excel. Another thing that I want to talk about is functions in Microsoft Excel. So for example, if we were to click on this little f sub x icon right here, that would then give me a list of functions that I could insert. And here's some of the more recently used. If you don't know what the functions are, a lot of times you won't know what they are just starting out in this program. You can kind of type a brief description, and so say I want to calculate the sum of multiple cells, for example, and I click go, and then that gives me the list of functions that most closely match my description, and the function that I want in this case is called sum. So just to show you how we would use this, in this cell I would say equal to, and then sum, and then it has to be followed by a parenthesis, and then in parentheses you can sum up whichever numbers you want. So say for example that I wanted to sum up all of these volume numbers, well, I would just highlight them all and then put another parenthesis, hit enter, and there is now the sum of all the volume numbers. And there are a lot of functions in Excel that can make your life easy. I just want you to know for now that those functions are out there. As we get more into using spreadsheets, we'll talk about the different functions that you could possibly use. Okay, so that's a brief overview of how we would handle and manipulate data in Excel. Now I want to go into how we generate an XY plot. An XY plot is something that you're going to be using a lot in your experiments in as far as assessing the data and analyzing the data and presenting the data. So I've created already a worksheet here called raw data. If you click on that, so this would be, say, some load deflection data that you got. You put a specimen in a machine, you pulled on it, and you measured load and deflection, and now we want to plot a stress strain curve based on that data. The area for the specimen is calculated right here. And actually here, let me show you how we would calculate that. So say the specimen has a 1/2 inch diameter, then its area would be pi d squared over 4, right? Okay, so I would, in this area cell, I would then insert equal to pi. Now Microsoft Excel does have the number pi already built into it. One thing you have to remember though is when you type it, you have to put in a parenthesis. It doesn't know what the letters pi mean, but if you put in the parenthesis, it realizes it's the function pi, which is 3.14159, etc. Okay, so equal to pi times diameter squared, and I said it was a 1/2 inch diameter, so 0.5 raised to the second power divided by 4. And that would then calculate the area of my specimen. We're also going to assume that the gauge length for my specimen is 2 inches, and we're going to then create our stress and strain curve. Okay, so the first thing we have to do is we have load and deflection data. We have to convert that into stress and strain data, and so I'm going to create 2 columns here. I'm going to call this one stress, and I'm going to call the next column strain, and my units for stress are going to be KSI, and my units for strain are going to be inches per inch. And I'm just going to quickly add some double lines that would be located right here underneath, just to kind of clean it up and make it look nice. Okay, so stress is going to be equal to load divided by area, right? Kips divided by this area. And so I'll say stress equal to cell A7 divided by B1. There's the stress. Of course, load is 0, stress is going to be 0. Now, you'll notice one thing. As I copy this down, it's going to update the numbers on those cells. So, for example, I just copied it down 1 cell, and now my stress is being calculated as load divided by gauge length. So we want the load cell to increase by one number, but we want the area to stay the same every time, right? And so there is a trick in Excel that we can use to lock the number from updating. It's a dollar sign. So for example here, I want the load to update, so I want the next one to be A8 divided by area, right? So in order to lock that number, I would then put a dollar sign right in front of it, and now you'll notice as I copy down one cell, it updated the load value, but it left B1 the same. Okay, so strain then would be equal to our deflection divided by the gauge length, and again I'm going to put a dollar sign in front of the 2, so I lock that value from updating. I only want to update the deflection value. And what I can do now is I can just sort of copy all these formulas down for all of the data, and you'll see here then I have now stress and strain data. Okay, so now we want to generate an XY plot, and the way we do that is there's a few ways to do it. The way I like to do it is we go insert and scatter plot here. We have options. We can do a just data points connected with smooth lines, no data points with straight lines, no data points. I like personally just plotting data points because that's the actual number you're measuring in the lab. You're not, all these lines that are drawn in between data points are inferred. The data points are the actual measurement. So let's select data points. I'm going to move my columns over a little bit just so I can kind of see my chart and my stress strain data. There we go. Now the way to select data is if you right click here, you can choose, you right click the blank chart area and then you choose select data. And data chart range, you could highlight the entire range of data. The program will then decide what is X and what is Y. I don't like it when the program decides it for me, so I just tell it what's X and Y. So I'll click right here, I'll click add data, and then it'll prompt me for a name, X values and Y values. And the X values, we want to plot strain in the X plot, so I'll then highlight these X values. And for the Y values, first I have to delete this bracket 1, and then I go and highlight all the Y values. And here we go. Alright, and then I'll just click OK for now and say OK again, and let's see what my chart looks like. Okay, so there's my stress strain plot for the data. Now I just want to show you some of the editing things we can do here. For one, this data is called Series 1. That really doesn't mean anything, so I'm going to go ahead and just delete that for now. We'll talk about adding a legend in a second here. So what else can we do to modify this chart? If you see here in Chart Tools, we have Design Tools, Layout Tools, and Format Tools. Well, we need to label our axes. It's not okay to have a chart without labeling axes, so I'll go into Axis Titles and Primary Horizontal Axis. I'll add one below, and on that title I'll call that Strain, and I'll give it units inches per inch. I'll also add a vertical axis, rotated title, and on the vertical axis we have stress, and the units for stress are KSI. Now it's really not appropriate to show stress to three places past the decimal. We're not measuring stress that accurately, and typically I would show stress with no places past the decimal. There we go. And strain, we could probably show that to 4 to 6 significant figures, depending how we're measuring it. So number, I'll say 5 decimal places. Okay, other things we can do here is we can add grid lines. Right now we just have a primary horizontal grid line. sometimes I like to show both major and minor grid lines. It helps you when you're trying to measure something off a picture. And so the minor grid lines are lighter and the major grid lines are heavier, and then also some vertical major and minor grid lines, and that would look like that. Other things we can do is add a chart title, centered overlay title. No, we want to do above chart, so it automatically resizes our chart. And in this case, we'll call this stress strain diagram. And then finally, let's add a legend here. Now you notice we could have a legend where it actually resizes the chart, or what I like to do is just overlay the legend so that it doesn't resize the chart. Now with this legend, it's kind of hard to read because it's transparent at this point. So if you were to double click it, you could then change its properties. And so I will give it solid white fill, and so you can actually read what's there. So now the data is listed as Series 1. Well, that doesn't really mean anything to me. So how do I change the name of my data? That actually happens when you're adding the data initially, and I didn't do it. I didn't give it a name. But I'll show you how you can go back in and re-edit the data. So if I were to right-click the chart area, and now you have to be careful because sometimes it's going to right-click grid lines, or sometimes it'll right-click data, and I really just want to right-click the area. I can go into Select Data. Here's my Series 1. I'll click on Edit, and then I'll give it a name. And so let's just say that this happens to be a high strength steel. And so I'll call this high stress strain curve for high strength steel. And then there we go. Now we have a proper name in my legend. Finally, if you were to double click the data points, you could actually change how those look. For example, you could go to and change the size. Maybe I want them to be round. Instead of size 7, I'm going to change them to size 4. Marker line color, you could also give the marker a solid line just to kind of make it stand out a little bit better. So it looks something like that. So there's all my data points. There's my stress strain curve. I have a legend. I have units. I have labels. And now next thing we'll do is show you how we can print the data. One thing you can do is if you have this chart area highlighted and then go into File, Print, you notice that it will just print the chart. Now if I were to have my cursor say I clicked on one of the cells over here or something like that, and then I were to go into File, Print, notice it's going to print the workbook and the chart. Okay, and another thing that's useful that you'll need to know is that you can quickly copy and paste this into Microsoft Word. So if you were to click the chart area and then just hit Control-C, or you could also do File, Copy, and then open Microsoft Word, you can either paste it as Control-V, or if you go to Paste Special, you have different options. And I like to just paste it as a picture. Usually I'll choose an enhanced meta file and paste it like so. So in your lab reports, it's very easy to copy and paste from Excel into Microsoft Word. Okay, so that's how we plot an XY scatter plot. We've talked about how we actually use our cells to manage and manipulate the data. We talked briefly about functions. We'll get more into functions as we use this more and more. And we've also talked about a brief overview of what Excel looks like. Okay, so that's it for this Microsoft Excel tutorial. If you have any questions, please let me know. Otherwise, good luck and have fun.